The center of gravity of a body is the point about which algebraic sum of moments of weights of all the particles constituting the body is zero. The moment of all the masses should be zero. Otherwise, it will not be called center of gravity. Like take an example of this rod. So let's say it's a uniform rod. The mass is distributed uniformly. So we can consider like we have this kind of distribution. Right? So particles here, we can think of them as spheres. And the similar particle, because it is balanced from the midpoint, which is the point of center of gravity, same number of particles will be on this side, such that the the moments, like for example, this moment will be balanced by 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 this. So that is why this is the special point where it is happening, where if we see all around, if you see the masses, their movements are canceling out, balancing on the other side. So the net movement of all the masses will be zero. The center of gravity of a hollow cone of height h, it is at distance x from its vertex, where the value of x is. See, the formula of the hollow cone center of gravity is h by 3, but that h is taken from the ground, from the base. So this is the base. And from here, we learn the formula that for a hollow cone, it will be h by 3, so this much height. But we need to calculate from the vertex. So that was a different thing on in this question. Like they're asking what will be the height from the vertex if you see. So we just have to imagine that it is x. Now we can say x plus h3 has to be h, the total height of the cone, and we will solve this, and we will get 2h by 3 as answer. So C will be the answer for this question. Where should be the center of gravity of a body be located for a stable equilibrium? So both A and B will be the option above the base and near the geometrical center. Now this is kind of a confusing question because they are assuming, that this textbook is assuming that we are considering only the simple regular shapes, like like a triangle, like a rectangle. So it should be near the geometrical center of the bodies, and it should be near the base because we they are imagining the shapes like this. So closer to the base, the better it will be. But actually, if you see the practical sense, it doesn't make sense. There can be bodies whose, for equilibrium, the center of gravity will not lie near the base. But anyways, we will take a simple example, keep it simple, and then we will say that both A and B can be the correct answer for this question. Fourth, two objects have the same mass but different shapes. Which objects would have a higher center of gravity? The one with the smaller base. See why the smaller base will have higher center of gravity. So here are two shapes, two different shapes. Okay, so I've just flipped it. So now you will understand what will happen if we have a bigger base above and or the bigger base at the ground level. So see the height, because mass mostly is lying here. Most of the mass is down here. The center of gravity will be near that. So center of gravity will lie around here. But here, because the mass is above of the body, most of the mass, so the center of gravity will be above. So it will have more height. So that is why if we have a smaller base, then the center of gravity will be at the more height. A hollow cone is kept upright on the table. Upright means straight, we have kept it. When sand is slowly poured in it. Now what we are doing is we are pouring sand into it. The center of gravity of the cone sand system. Okay, so it's not only cone. Tell us about the sand also. So what will happen? See, this was the, let's say this was the cone. It was a hollow one, and we know that h by 3 from the base will be the center of gravity at this point. So this will be the COG without sand. Without sand. Now what will happen if we start pouring sand? What will happen is when we pour the sand, it will get accumulated on the base. So we are getting more mass at the bottom. So this center of gravity will shift down here, right? And we are pouring it more, it will come down more. And now what will happen when it will reach? Now the upper part of the cone is getting filled. So what will happen? The center of gravity will move up now. So what it is happening to the center of gravity, if you see, as we go on filling, first it is going down and then it is moving up. So that is what we have to understand here, that it first falls and then rises, because rise happens because now mass is getting in the upper part of the cone also. A child starts eating the ice cream from a fully filled cone. What happens to its center of gravity? So if the cone is like that, I have in this position I have imagined the cone. So now he starts eating. They will eat from here, right? The shape will reduce. So now only this much cone is left. The height has decreased. So what will happen? The center of gravity was here, but now because this mass is eaten away, so the center of gravity will shift down. So it will count, it will falls continuously. There is no point of getting it up because we are not putting mass into it. We are eating it. This child is eating the ice cream, so he will finish it off. It will go down like this, then this, then this, then this, and center of gravity will keep falling. So that's why it is the option B. It falls continuously. Seventh question: a hollow spherical tank is half filled with oil. If water denser than oil, okay, is added, the overall center of gravity will. So this is a kind of interesting question. So what will happen? Firstly, the tanker was half filled with oil. So the center of gravity will be down here, let's say. Okay, so this was my center of gravity without pouring water. Now we are adding water. It is denser than oil. So if we pour water, it will go down, right? It will go down. But now in this case, what is happening that because it is we are dealing with liquids, this oil will rise up, right? But more mass, denser things is coming down. So it will fall down, right? It will fall down as we are pouring water. Eventually, what will happen? Half of the sphere will be filled with oil, and below we will see that water is filled. So the center of gravity will always move downwards. In this case, it will not happen. This case will not happen. Only move downwards. A hollow rectangular box is standing upright. A heavy brick is placed on top of the box. The center of gravity of the system will. So what we are doing, hollow rectangular box, let's imagine it like this. Rectangular box it is, so it will be a cuboid kind of shape. This is kind of a rectangular box we are having. So heavy brick is placed on top. So initially it was the COG was this. Now if you put a brick above it, like this, you have put brick is very heavy. So most of the mass of this system is now above. So what will happen? The COG will go towards where the more mass is there, or it will move upward. So the B will be the option.